Welcome back students to the next module. Here we will be discussing about conservation of momentum, equilibrium of concurrent forces and friction. Law of conservation of momentum. According to this law, the total momentum of an isolated system of particles is conserved. In other words, when no external force is applied to the system, its total momentum remains constant. Recoiling of a gun, flight of rockets and jet planes, etc. are some simple applications of the law of conservation of linear momentum. Mathematically, we can say if F external is equivalent to 0, then P is a constant. That is, if the external forces acting on the system of particles is 0, then momentum remains conserved. A group of forces which are acting at one point are called concurrent forces. For the concurrent forces to be in equilibrium, their resultant force must be 0. That is, if the sum of the forces acting at a point is equivalent to 0, then we can say that the concurrent forces are in equilibrium. Mathematically, if sigma F is equivalent to 0 or F1 plus F2 plus F3 plus etc. is equivalent to 0, we can say that these forces are in equilibrium. We have learned about friction in smaller classes. The opposition to any relative motion between two surfaces in contact is referred to as friction. It arises because of the intermeshing of the surface irregularities of the two surfaces in contact. There are two types of friction: static friction and kinetic friction. The frictional force that arises when an object is stationary or static is termed as static friction, and the frictional force which exists when there is relative motion between two surfaces is termed as dynamic friction or kinetic friction. Static friction is always a little more than kinetic friction. That is, the magnitude of kinetic frictional force is proportional to the normal force. Limiting frictional force. This frictional force acts when body is about to move. This is the maximum frictional force that can exist at the contact surface. So we have seen the friction that occurs when the objects are not moving is the static friction, and it is a friction that keeps the object in place. For example, a box sitting on the ground, your books sitting on a table, your backside against the chair. Laws of friction. The magnitude of limiting frictional force is proportional to the normal force at the contact surface. Normal reaction force is equal and opposite to the weight of an object. The magnitude of limiting frictional force is independent of the area of contact between the surfaces. There is a term called coefficient of friction, which is denoted as mu. Coefficient of friction between two surfaces is the ratio of their limiting frictional force to the normal reaction force between them. Angle of friction is the angle which the resultant of the force of limiting friction F and the normal reaction R makes with the direction of normal reaction. So we have seen limiting friction F is proportional to normal reaction N. Replacing the proportionality sign with a constant, we can write F is equivalent to mu S into N, where mu S is a constant known as coefficient of static friction, and its value depends on nature of the surfaces in contact. This limiting friction is proportional to normal reaction. Likewise, the force of static friction is also proportional to normal reaction. In other words, mu is equivalent to limiting frictional force by normal reaction, or mu is equivalent to F by R. When there is no relative motion, mu is equivalent to mu S, that is the coefficient of static friction, and when there is relative motion, mu is equivalent to mu K, which is called the coefficient of kinetic friction. Hope you might have got an idea about frictional force and the types of friction. Thank you, dear students.